First thing we're going to talk about is the types of numbers, types of real numbers. So this turquoise bubble is all real numbers. Real numbers are basically every number that you can think of is a real number. At some point, we'll start talking about imaginary numbers, but we're not there yet. Inside real numbers, there's natural, whole, integers, rational numbers, and irrational numbers. Notice this one on the left, the natural, whole, integers, rational. Do you see how it's a bubble within a bubble within a bubble within a bubble? What this means is if I take a natural number, for example, 3 is a natural number. 3 is a natural number. It's also a whole number. It's also an integer, and it's also a rational number. It is everything that it is within. 3 is not an irrational number. An irrational number is not going to be any of these. A natural number is just a counting number, 1, 2, 3, 4, 5, and so on. No decimals, no zero, no negatives. There's not even a spot for it here because we don't really talk about natural numbers. We start with whole numbers. Whole numbers are 0, 1, 2, 3, etc. There are no decimals, and there are no negatives. Integers are all of the whole numbers plus negatives. So -3, -2, -1, 0, 1, 2, 3, and so on. There are still no decimals in the integers. Rational numbers are any decimals that can be written as fractions. I'm running out of space. For example, 0.5 is the fraction 1/2. 3 is the fraction 3/1. Even whole numbers and integers, you can write those as fractions if you put them over 1. So these three things are linked. If it's a whole number, it's also an integer and a rational number. If it's an integer, it's also a rational number. If it's a rational number, it's pretty much just a rational number. I'm going to call whole numbers A, integers B, and rational numbers C. We'll call irrational numbers D. Irrational numbers are decimals that cannot be written as fractions. Some common irrational numbers are pi, the square root of 2, the square root of 3, the square root of 4 is 2, so that's not an irrational number, square root of 5, on my calculator, if I type in the square root of 2, I get this crazy long decimal that keeps on going and doesn't ever stop. It just keeps going and doesn't repeat. If I try to change that to a fraction, so we learned yesterday, math button, enter, enter, it doesn't work. It doesn't change it to a fraction. So if I gave you the number -2, how would you describe -2? Is it A? Is it a whole number? No. Is it B? Is it an integer? Yes, so it's B. Is it C? Yes, it's also a rational number. If it's A, it's going to be A, B, C. If it's B, it's going to be B and C. If it's C, it's just going to be C. What if I gave you the number -3/4? that would just be C. If I gave you the square root of 7, the square root of 7 would just be D. It's a decimal that keeps on going, doesn't terminate, doesn't repeat, can't be changed to a fraction. So when in doubt, put the number into your calculator, try to change it to a fraction. If your calculator won't do it, it's an irrational number. On your assignment, it's going to be a table, and there'll be a couple of numbers and then a column for whole numbers, integers, rational, and irrational. And you'll have to click yes or click for yes or leave it blank for no. But is it a whole number? Click or not. Is it an integer? Is it a rational number? Is it an irrational number? Okay, on your assignment, we are not going to plot these numbers on a number line. The number line is really just there if you need help deciding which one is bigger. We are going to use a less than or greater than symbol in between these numbers to show which one is bigger. So you may have to convert these to decimals to be able to compare them better. If you heard that on the video, that surprised us too. Okay, -4/3, I believe, is the fraction -1.3 repeated. -5/4 is -1.25. Which one's bigger? The -1.25. With negatives, it's always a little bit tough, even for me, because I'm like, 1.33 is bigger. Oh, but it's negative. So -1.33 is farther away from 0 than -1.25. If you do need to draw this out on the number line, you can. 1.33 is a third of the way between 1 and 2. -1.25 is a quarter of the way between -1 and -2. I forgot my negatives on here. All right, 9/4. What fraction is 9/4? 2.25. And 6/5? 6/5, that's 1.2, I think. Yeah. Which one's bigger? 2.25. And on number 3, I want you to plug those into your calculator and decide which one is bigger. On your assignment, it'll give you a problem like number 4, but then it'll give you multiple choice answers. So what I would do on number 4 is just record what each of these numbers is. -1/2 is 0.5. 13/4, 13 divided by 4 is 3.25. And then I've got -3 and -6. So the biggest one, the smallest one is -6. You're going to look for an answer choice that starts with -6. Whichever ones don't have -6, there is an answer eliminator tool, so you can cross off the ones that you know are not the correct answer. The next number should be -3. Again, cross off the ones that don't have -3 as the second answer. What's the third? -0.5, and then 2, and then 3.25. Honestly, on a multiple choice question, if you identify that this one should be the first number shown and this one should be the last number shown, you can probably find the correct answer pretty quickly. You might have to also look at which one is the second in that list. Do you remember the terms commutative, associative? Have you heard those terms before? No one remembers them. Now, I have them committed to memory, but I've also been teaching this class at least 2 times per day, every day for the last 12 years. So I have these perfectly committed to memory, but it's totally understandable if you don't. So if you are allowed a 3x5 note card on the test, which you are, I would definitely write down something about the commutative and associative property and maybe identity and inverse, so that if those questions show up on the test, you have some sort of a reference point on that card to help you. The commutative property is all about changing the order. So I'm going to write order next to commutative. The commutative property of addition means that you can switch the order that you add things. 2 plus 3 is the same as 3 plus 2. They both give you the answer 5. The commutative property of multiplication says that you can switch the order when you multiply. 2 times 3 is the same as 3 times 2. They both give you the answer of 6. The associative property deals with switching the parentheses. And I never remember if parentheses is supposed to be IS or ES. I change it up every time I write it, I think. So if I add the first two together and then add the third one, that's the same as adding the second and third one together and then adding the first one. The order, where the parentheses are located, switching the order of the parentheses still gives you the same answer. The next two are easy to get screwed up. Identity means you end with where you started. So I'm trying to write that small so I can get in there. You end with your starting value. If I take the number 5 and add 0 to it, my answer is still 5. I started with 5, I ended with 5. That's the identity property. If I take the number 10 and multiply it by 1, I still have 10. I started with 10, I multiplied by something, I ended with 10. I haven't changed the value of the number. That's the identity property. Inverse is when you kind of undo it. When you solve equations, what you're doing is you're using inverses. So, I'm about to blow your mind. Subtraction doesn't exist. It's a lie that your elementary teachers told you. It's a complete myth. Subtraction does not exist. Huh? Subtraction is just the addition of negative numbers. If I take the number 5 and I add negative 5 to it, I end up with 0. Adding negative 5 is the same as subtracting by 5. But here's the deal. In elementary school, if you told little elementary kids, all right, so we're going to add negative numbers here. Can elementary kids' brains comprehend the concept of negative numbers? No, they would probably just sit and cry and hate everything. So we teach them subtraction because that makes sense. You've got 5 things. I take those 5 things away. I subtract 5. What are you left with? You're left with 0. But what you're really doing is adding the opposite. When you add the opposite and get back to 0, that's the inverse. 5 and negative 5 are inverses of each other. Okay, second myth from elementary school. Division is a lie. Division doesn't exist. Division is just the multiplication of the reciprocal. If I take the number 2 and multiply by 1/2, I end up with 1. Multiplying by 1/2 is the same as dividing by 2. So division isn't real, you're multiplying by the reciprocal. But in elementary school, 20 beans on the desk, split them into 5 piles, you've got 4 beans in each pile. You're dividing them into piles. That's what makes sense in our brain, so that's what we learn. 2 and 1/2 are called inverses of each other. When you're multiplying, they undo each other and get you back to 1. And then distributive property, that's where you multiply the number into the parentheses. I feel like that's the one that you're like, oh, distributive, I know that one. I got that one. I'm good. Right? Is that accurate? So on the next page, I would like you to try identifying the properties that are shown. So take a moment and try this on your own. All right.